Hi, planning on taking ME 2110? This can be a stressful and time-consuming class. I've been a lab assistant for 3 semesters, ranked pretty good, and placed pretty good, so I've got some pro tips for you. So let's get into the video. Okay, first tip, choose a late lab section. You can get ideas from people on tasks from earlier in the week. Also, if you can get some insight, you'll want to pick a professor that lets you choose your team for the final competition. The last thing you can do before class starts is making sure you have a lot of your own tools, such as drills, rotary tools, hacksaws, etc. I hear a place like Phi Kappa Theta is pretty good for that. You should consider rushing. So just a brief overview of the competition. It's about 5 tasks, usually pulling, pushing things from the side, and putting or taking away things from the centerpiece. When I took the class in the fall semester, there were about 60 teams and 7 rounds. 4 teams competed at a time, and the top 2 moved on to the next round. So at the very least, for building an actual robot, you're going to want to do at least 1 or 2 tasks really well. Building independent mechanisms are good in case of one failing. Also, a lot of people don't consider blocking or descoring mechanisms. I showed my old design to my friends in a later semester, and they improved it and ended up getting 2nd place overall. For the required dimensions of the robot, we were given the following. I found it a good rule of thumb to build within 1 inch shorter of the dimensions for good tolerancing. One really useful tool I'd recommend is CAD, or Cardboard Aided Design. This was great for prototyping, as our team could quickly cut some scrap cardboard to see how our machine would interact with everything. We'd then take a picture, trace it in AutoCAD, and laser cut the piece out of wood. Needless to say, it helped everything perform really well. Sometimes the professor provides general CAD files of the field. I would recommend also measuring the field in person. In competition, all fields are slightly different, so you should account for that. Here, you can see me doing Crayola CAD, which is like an advanced napkin sketch, to get an idea of measurements, and trying out a ramp to retrieve a gauntlet for the 2018 game. Now is when I recommend you pause the video. This is an example of what your LabVIEW program should look like for the final competition. It basically uses one timer to activate everything when your digital input or banana plugs are touched. Here is an equivalent program that is actually very common in 2110. Don't do this. The issue is you can't stop your program without running the flat sequence for the whole 40 seconds. This can happen if you touch your banana plugs briefly and unintentionally. As a side note, LEDs are also good indicators to show your MyRio is done booting and your program is running. Home Depot is great for materials like yardsticks. They're each $1 and you don't have to measure them. Ace Hardware has lots of screws and is in Midtown. The screws to mount your motors are 3mm metric, and you can get them here. To charge your pneumatics at home, one cool trick is to take your 4 and 6mm tubing, press fit and tape them together, and then just use a normal bike pump to pressurize the air. You're usually permitted 5 mouse traps to use on your robot, and they can be quite annoying. To make them last longer, use zip ties. You can also use the mousetrap spring on a modified hinge by removing the pin, dremeling out a spot for the spring, and assembling it. This is the layout you should have for your MyRio and breakout boards. Looking more closely, the driver board given to you outputs about 12 volts. If you're not using all of your mechatronic components, you can check the voltage direction and attach some 12-volt LEDs. If you're looking to paint your robot, don't do it outside the MRDC and leave marks everywhere. Instead, there's a painting booth owned by the Invention Studio you can use. It's right outside the MRDC and down a set of stairs. There's often free paint and a table with ventilation available. I would not recommend building a car-type robot. They're slower, they get stuck a lot, people get stuck on their own cables, the robots get misaligned. Just don't do it. Now I'm going to show you how to modify your drawer slides, which are commonly used to traverse to the centerpiece from the starting block. Don't buy the cheap drawer slides that aren't assembled. Everyone ends up throwing these out. Here's a comparison of the drawer slide speed with no modification, with most of the grease removed, with WD-40, and with silicone spray. WD-40 tends to last less time since it drips a lot more, and this can get you disqualified if it happens in competition. The silicone spray has no odor, and I would recommend it as my first choice. Knowing how to extend your drawer slides can reduce the cost and increase your speed. You can see that this team bought one pair of 24-inch drawer slides and could easily reach the centerpiece. A lot of teams will compound several drawer slides, but this will increase the weight and inertia that makes it harder to push them to the center. To extend your drawer slides, start by bending back the tab on the end and remove the middle rail. Be careful not to let the ball bearings spill everywhere. To remove the small rail, simply pull the ball bearing carriage and pull the rail out. While you can, clean out all the grease with paper towels and water. You should do this before lubricating it. Now that you have the middle rail removed, you can cut the plastic bearing holders and reinsert them. Remember to bend the tab back. To extend the small rail, pull off the plastic piece, bend it back so it will stay flush to the rail, and mount it to the lowest hole position, or a hole you drilled, with a 440 screw cut to size and a lock nut. Reassemble everything, and you should notice a significant difference in slide length. To help with mounting things to your drawer slides or other parts of your robot, I would highly recommend at the beginning of the semester buying a 100 pack of 1.5-inch 440 screws and lock nuts with some washers on McMaster. To add to the shopping list, it is so valuable having motor hubs, and the Tetrix ones on Amazon work great. Additionally, weights can be super valuable, and you can get them from your old jump ropes, or possibly from an old internship if they have a bunch of scrap steel. I would generally recommend avoiding the 3D printers in the Invention Studio unless you are making small parts. Often enough, you can cut your parts on the laser cutter in much less time. Remember to drill your pilot holes to avoid splintering. Remember in competition to pull your banana plugs from the plastic casing and not the wires directly. A lot of teams will do it the wrong way, and often their robot will not activate as a result. To strengthen your banana plugs, you can unscrew the caps, pull out your wire, strip the wire if you need to, reinsert the wire, wrap it towards you tightly, and screw everything back together. For judging in competition day, practice your presentation. Judges really like creativity and good-looking robots similar to your CAD design. Once you get judged 3 times, you'll head over to the mark and enter an auditorium. The top area is perfect to set up at ground level. The main priority is to not disqualify. Make sure your robot moves even if it doesn't score points. Have a checklist with tasks for everyone to set up the robot, take your time when boxing, plug in all your power and banana plugs, return the field elements after your round, and don't curse. The TAs will display information during the rounds. I recommend bringing binoculars to read everything. If you reach the quarterfinals, avoid changing things on your robot. People will tweak their code last minute and not move in the final. So to leave you with some final tips, analyze what you can do to get more points, go for speed, descoring, etc. If you just want a good grade, focus mostly on reports. Try to sleep, this will be a very time-consuming class. Have fun, you never know what will happen. And rush Phi Kappa Theta. We honestly have a lot of MEs that can give you advice, and we'd love to see you stop by.